today we are going to model using quadratic functions, consecutive integers. So problem number 1. When Albert flips open his mathematics textbook, he notices that the product of the page numbers of the two pages facing him is 156. Which equation could be used to find the page numbers that Albert is looking at? Show your work. So what do you know about page numbers in a book? They always go up by 1, right? You start on page 1, you read, you get to page 2, you get to page 3, so on and so forth. We call these types of numbers consecutive integers. So they're just whole numbers that follow each other without gaps. Now, Albert notices that the two pages open that are facing him, when they're multiplied together, they give him 156. So first off, we're going to look at all of the problem choices that they give us and look for the one that says product. So the operation here is x plus 1. There is no product. X plus 1 plus x plus 2, no product. X plus 1 times x plus 3, that is a product. Okay, so let's investigate this answer choice. And then x times x plus 1 equals 156. There is a product occurring there, so let's investigate those answer choices. Which equation could be used to find the page numbers that Albert is looking at? Well, which one models consecutive integers? So let's say that Albert was on page 12, right? So Albert was on page 12. If x is equal to 12, then let's substitute that into answer choice 4. We have 12 times 12 plus 1. Does that give me 2 consecutive numbers? It sure does. I have 12 times 13. Does that equal 156? I don't know. Let me check on my calculator right up quick. It does. Okay, cool. So it looks like Albert is on page 12 and page 13. And he noticed that when he multiplies these together, he gets 156. So this answer choice 4 is modeling consecutive integers. Because let's say he was open to page 12 and we were looking at answer choice 3, he would really be on page 13 times page 15. 13 and 15 are not consecutive integers, so we would definitely reject answer choice 3. So consecutive integers, we just talked about those real quick. The examples would be 1, 2, 3, and 4. These are whole numbers that follow each other without gaps, and we model them with algebra by saying the first number is x, the second number is x plus 1, x plus 2, x plus 3, so on and so forth. Whereas you're counting and you're just adding one more to the number that you started with. Consecutive even integers. Consecutive even integers are 2, 4, 6, 8. You get the idea. The way that we model those with algebra is we first have to start with a number that we definitely know is even. And a number that is multiplied by 2 is always going to be even because every even number is divisible by 2. So if we right off the bat start by making sure that 2 is a factor of that number, we know it's going to be even. And then to get to the next even number, we've got to add 2 because an even plus an even is an even. So we would do 2x plus 2, 2x plus 4, 2x plus 6, so on and so forth. That's how we would get consecutive even integers. Now, consecutive odd integers are odd whole numbers that follow each other. So we can say 1, 3, 5, 7, 9. Those are all common consecutive odd integers. So we know that an even plus an odd gives us an odd. So if we start with a definitely even number and we add an odd, we're definitely going to be starting with an odd number. So to get to the next odd number, we would have to add another odd number. So we would get 2x plus 1, 2x plus 3, 2x plus 5, so on and so forth. So these are going to be the equations that we use when we do consecutive integer problems. Let's try an example here. We have Tamara has 2 sisters. One of the sisters is 7 years older than Tamara. The other sister is 3 years younger than Tamara. If you'll notice, Tamara pops up quite a bit. Nothing else is mentioned about the names of the other sisters. So let's put everything in terms of Tamara. So we're going to let Tamara be X, and then we're going to put our information about the other sisters in terms of Tamara. Sorry, just one sister. There we go. So we are putting all information on sister 1 and sister 2 in terms of Tamara. One of the sisters is 7 years older than Tamara, so I've got Tamara plus 7. And the other sister is 3 years younger than Tamara, so I've got Tamara minus 3. Now the problem says that the product of Tamara's sisters' ages is 24. Product is multiplication, and it's the sisters' ages, so I'm going to put those expressions right there. And all of this is equal to 24. And now the problem is asking me, how old is Tamara? Okay, so remember, we let Tamara equal X. So how old is Tamara? We're really just going to be solving for X here to find that answer. So let's multiply out X plus 7 times X minus 3. X plus 7 times X minus 3 is going to give me X squared plus 7X minus 3X minus 21. Let's bring this 24 over to be with its mate here, and we've got X squared, combined like terms, plus 4X minus 45 equals 0. So now I can totally factor this and get X plus 9 times X minus 5, still equal to 0. Zero product rule says that I can set this factor equal to 0, and I can set this factor equal to 0, and I can solve for my two X values. So I've got a minus 9, X equals negative 9. I've got a positive 5, X equals 5. These are my two answers for possible ages of Tamara. Now let's think about this. Have you ever met somebody that was negative 9 years old? No, neither have I. So in terms of the problem here, negative 9 doesn't make a whole lot of sense, and we're going to go ahead and reject that answer choice. X equals 5 makes wonderful sense, though. We totally know people that are 5 years old, right? So how old is Tamara? Let's make sure we put our answer in a full sentence, like this is the Regents. We would say Tamara is 5 years old. You should probably include the period in the box, but